So I'm Tom Bragg, and I'm a trustee of Cambridge Carbon Footprint, which has been running open eco homes every year since 2010. For years, I've been fascinated by Wookey's thorough, mainly DIY retrofit. And as an engineer, he's investigated and found solutions for hundreds of problems. So it's a real delight to hear from him now about the big picture and also all those details.
Hi. Yes. So I bought my 1960s house in 2007. It's a fairly typical building of that vintage. It's a detached house, been previously rented for a decade or so. So it was in quite good decorative order, but we moved in January. It rapidly became clear that it was cold and drafty and in need of some improvement. So just to give you an idea, that is the plan view. So it's a fairly square detached house with a big lounge and a fairly small kitchen, 3 bedrooms, and an unhelpfully small bathroom, and a detached garage. It already had double glazing and cavity wall fill, although we fairly quickly discovered that this whole section of cavity wall here hadn't been filled because this plant was covering it, and clearly the cavity wall people couldn't be bothered. It had been like that for 10 years, but nobody had noticed until I had a look. To be fair, they did come back and fixed it once we pointed this out. But yeah, do check that your cavity wall has actually been installed all the way through. I also found, having taken out a lot of bits of windows and things, that there are a lot of gaps in cavity fill. It's nothing like as complete as the theory suggests it should be in a lot of cases. So I had some experience of DIY from a previous house, 1930s semi here. It was one of those houses where an old lady had lived in it since it was built in the 30s, and so nothing had been done since about the 50s. So we insulated the walls, insulated plasterboard, fitted central heating, fitted double glazing, and generally updated things. However, I didn't know much about airtightness back then, so we didn't do the bit between the floors, which it turns out is important, and we didn't put that much insulation in, and we didn't do below the suspended floor before we covered it in things, and then it was too much like hard work. So we decided this time we'd do a better job. I learned a lot from the Navitron forum and the Green Building forum. Unfortunately, Navitron is now defunct, but there are plenty of useful resources online. You can learn about how this stuff works. So I need to talk a bit about nomenclature, otherwise I'll use lots of terms that I haven't explained. So U values is critical. That is the heat loss per unit area of a wall or a roof or a window, and smaller is better. So 5 is terrible, single glazed windows. 0.1 is really good, like a passive house wall. Remember those numbers. Psi value is the linear version of that. So that's like the heat loss around the edge of a window or around the edge of a door or where a wall joins a floor. I'll try to get into that because it's getting quite technical, but I might mention it. There's internal wall insulation, IWI, and external wall insulation, EWI. This house has both of those, unusually. Mechanical ventilation, heat recovery, we'll talk about that later. Then there's materials, expanded polystyrene, EPS, extruded polystyrene, XPS, which is much solider stuff. EPS is the standard white fluff that your fridge gets delivered in. PUR is polyurethane foam. That's that kind of orange yellow foam, usually with silver foil down the sides. You probably know it as Celotex or Ecotherm. There's also the ACB, is the Association of Environmentally Conscious Builders, who set retrofit standards, and I'm a member, and we have a monthly pub meet, which is a very useful place to come and talk about this stuff for your particular project in more detail if you want to. You don't have to be a member, just come along. We like talking about retrofits. Passive house planning package is just a spreadsheet, a really big, scary, complicated spreadsheet, but nevertheless just a spreadsheet. And it's a very good tool for working out how good your fabric is and what happens if you do this, and what if you put these windows in, and what if you insulate this part to this degree, and so on, which is different from the UK's standard assessment procedure, SAP, which is how houses are usually measured in this country, you know, A to F, which is not as good technically a measure. But it is useful for official purposes because that's how the government decides what's appropriate. Annoyingly, you can get a SAP rating of C on a passive house, because they don't measure things in quite the same way, which is really quite confusing. So in my opinion, the most useful measure of the fabric quality of a building, how good is this house, is this what the kind of final output number of the PHPP is kilowatt hours per meter squared. So what is the total heat load over the whole year per square meter of the building? Per square meter is, for this purpose, a special useful area number, so not the nominal area of the building, but the useful area, so not stairs and cupboards and bits of rooms that are too low to stand up in, that kind of thing. It comes from a German specification. So for our house, it's nominally 120 square meters, but it's actually only 96.5 in PHPP world, which makes quite a big difference to how well you have to insulate things. So it's important to understand the difference. So this building, as built with single glazed windows and empty cavities, was probably 380 odd kilowatt hours per square meter. So that's bad. That's like F or G and SAP levels. By the time we got it, it's 120. So that's with double glazing and cavity wall fill and some loft insulation. So where a lot of buildings are in the UK, probably. A decent retrofit level is less than 50. Which is what the AECB retrofit standard specifies, with some exceptions for buildings where you can't get there, usually really old single skin buildings. EnerPHit is less than 25 and Passivhaus is less than 15. So that's for new builds, the Passivhaus spec. The EnerPHit is the Passivhaus Retrofit standard, hence the weird capitalized PH in the middle. The point being that it's extremely difficult to get to 15 on an existing building because of things you just can't fix after they've been built, or at least not for a sane amount of money. But yeah, so this is really good. And that's, I would say that, if you're doing a retrofit, you really should be trying to get as far as AECB retrofit, if you can, 50 kilowatt hours per square meter. So this is the equivalent annual energy use that these numbers correspond to. Just so I've got some idea, the average UK energy use, this is for heating only, not everything, is about 13,000. So yeah, somewhere up here. And the other thing that's really important is airtightness. So the Passivhaus spec is air changes per hour. Passivhaus spec is 0.6, EnerPHit's 1, ACB retrofit is less than 2, and I reckon this building was somewhere between 5 and 12 when we got it. So I've done an awful lot of things over 14 years. Here's the list, which is clearly far too many to go over in the 20 minutes we've got. Obviously, I'd love to give you the 5-hour version of this talk, but you probably have lives. So what I will do is talk about a few of them, really, and trying to emphasize the principles behind what I've been doing rather than the specifics too much. So those are airtightness, thermal bridging, vapor movement, thermal mass, and solar gain. But primarily these first two. Vapor movement is a really big subject. That's another couple of hours talk. And it's much more important on older single skin buildings than it is on a relatively modern one like this that's got a working damp proof course and a cavity and that sort of thing. So we moved in and found that we had this ancient ideal Mexico boiler in the garage, which worked fine and sort of heated the house up. But we rapidly discovered that the pilot light was using 6 kilowatt hours a day, which is just shocking. And it's something like 8 times our gas use now that it's finished. So that had to go. And also the pipes just went across under the roof felt like this. A tiny bit of insulation, but really the garage was nice and warm. And the outside was being well heated, but it was a deeply inefficient system and had to go. Replaced it with a modern Wiesmann system boiler, primarily because I wanted to keep the hot water tank, because we're going to fit solar thermal, and you need a hot water tank for solar thermal because it collects heat slowly over the day. And you need to collect up the heat somewhere. So you can't really have solar thermal and a combi. It doesn't work all that well. Replaced an awful lot of massive uninsulated copper pipes with insulated plastic ones. And generally made things a lot better. The other thing we looked at early on was electricity use. So we went around and just measured things and found out what was using what. And for example, discovered that there was a Bell transformer in the electricity cupboard next to the door. The Bell had long gone. So, probably been sat there for about a decade, just using electricity, doing nothing, about 11 watts continuous. So, it's nearly 100 kilowatt hours a year for absolutely nothing. So I wonder how many other houses have such horrors. So I think one of the bits of advice I'd give is go around and measure stuff. You know, what is your gas usage, and what is your appliances using, and how much. And so you've got some idea of which things to do first, and which things matter and which things don't. For example, if you go on holiday for a couple of weeks, you turn everything off except the fridge and freezer, and maybe the boiler or some control systems, you can find out what your base energy load is. So ours was 1.15 kilowatt hours a day, which works out to 420 a year. So, you know, you're not going to get below that without buying a new freezer. The other thing we did was took part in an energy company trial, which was really useful. So they instrumented, a lot of separate appliances over a month and measured it and produced these nice, pretty graphs. So from that, you get to learn quite a lot of detail. So this is a typical day. All the red lines are every time the kettle went on. We clearly drink a lot of tea and coffee in our house. And then there's the dishwasher, I think there's a blue line. And then there's all the other things. So those are the high power devices. And then there's all the low power devices like TVs and fridges going on off all day. And those work out to be fairly similar levels of power consumption. This is over 2 weeks. You know, you can see here. So at this time, we had our old C-rated freezer and our new A++ plus freezer, which we just got. And as you can see, the C-rated freezer uses 3 times as much electricity as the new A++ plus one, which is why it's well worth replacing. It wasn't that old. It was probably 12 years old or something. So yeah, it's well worth replacing older equipment with stuff with better ratings. And you know, the dishwasher over the time uses about half as much as the freezer. Kettle's about the same. TV, it turns out, is nearly twice as much. So our TV used more electricity than we'd realised. It's again relatively old, and once it dies, we'll probably get a more efficient one. I also fitted solar thermal, which is actually relatively straightforward and not that expensive. Again, the Navitron forum was a great place to learn all the details, but basically you buy some vacuum tubes and stick them on the roof, do a bit of plumbing, so you've got a pump and a filling point and a one-way valve and a pressure relief valve, and that's it, and a little control system. So when the panels are hotter than the tank, you pump the water around. So what's slightly unusual is that we kept the existing old crappy hot water tank and put a thermosiphon on the side, so rather than buy a new tank with a solar coil in the bottom. And the point about this is that with this system, the plate heat exchanger gets hot from the panels, and then hot water rises to and comes in the top of the tank, whereas cold water comes at the bottom. So the tank fills up from the top with actual hot water, as opposed to the more standard system with the bottom coil, where you get more energy in total, but what you end up with is a whole tank slightly full of tepid water on a not particularly sunny day, as opposed to a small amount of actual hot water you can use at the top. So you actually get to use your boiler less this way, because we only put it in if it's at least 40 degrees C, i.e. hot enough to use for a shower. And this works very well, actually. It does us for 3/4 of the year, February to October, entirely. We don't need to use any other hot water heating, as long as you don't mind waiting a bit before turning the dishwasher on or whatever, wait for a sunny day. But obviously it's not that much use between November and January, and we use the immersion to fill in then. You can still get enough hot water to have showers, but not every day, and sometimes not for quite some time. The other thing we did was fix the loft. It had a little bit of fluff in, you know, just between the joists, but obviously we added a load more to get that up to between 300 and 400 millimeters, and also put in some hard standing areas for storing stuff and a walkway down the loft, which I would strongly advise is a brilliant idea. In the decade since, I spent a lot of time using this walkway to get to fix other things. So yeah, it's a very good idea. Other thing that annoys me about, you can buy an insulated loft hatch, but it only has like 30 mil of insulation on it, and you've put 300 in the rest of the loft. So that seems a bit wrong-headed. So I made one that was the same width as the same height as the rest of the insulation. Obviously, it's a bit bank door vaulty, but it works well. Oops. So we also fitted solar thermal because the feed-in tariff came into being in 2010, and that was a very good deal if you had some money to spend on solar panels. It paid for itself in about 7 years. So now it just makes us £1,000 a year. So our actual energy bills are enormously negative, but obviously that's not a thing available if you're starting now, but it was a good deal. We export 85% of our electricity because we go to work during the day. Well, we did until this year. One thing I would, this reminds me, is generally government grants are never available for DIY. So if you fit your own solar panels, you didn't get the fit. If you fit your own heat pump, you don't get the renewable heat incentive, and the green, whatever it was, grants system, again, wasn't available for DIY. All these things have to be done by professionals, which just illustrates that the government is only actually interested in generating jobs. They're not interested in getting the buildings improved, because if you could get grants to do your own work, you know, a half or a third of the cost, depending what it is, an awful lot more buildings could potentially get fixed. So I think that's quite short-sighted, but sadly I'm not in charge. So before I talk about thermal bridges some more, I should explain what I mean by that. So I'm here fitting a nice new door, which is much better insulated than the old one. But the problem is that, so here's inside and the slab is warm, and the door is just sat on these bricks. And so even if this door is really well insulated, the heat just goes straight through these bricks here, and bricks are a terrible insulator. So that is the thermal bridge. So it's bypassing this relatively well insulated element, and you know, this one could be as well, but there's a gap. So anywhere where you've got a lack of insulation is a thermal bridge. So it's also true around the doors, but I fix that by cutting a slot and putting some insulation in. Now, so unfortunately, because it's your front door, I didn't get to realize this until you take the door out and realize what the floor's made of and go, oh, but you can't fix it there and then. I didn't have any materials to hand, and you kind of need to put your front door back that day. So this actually had to wait a decade until we were doing the external wall insulation, and we got rid of the porch step so I could get to this and put in a thermal break under the door as well as around the sides. So this is compact foam, which is really useful stuff. It's basically expanded polystyrene, like the white plastic stuff, but really strong. So you can put screws into it. It's basically like a piece of timber, and you can put very heavy things like doors and windows on it. So it's a very useful component for problems like, how do I hold a door up, but in a thermally efficient way? It's made in Austria. So this is the reveals. So on this house, the reveals come, you know, the inner leaf of the bricks comes to here and then joins around the corner and goes straight out. So again, there's a big thermal bridge here. So even if you put some really good windows in, or your windows aren't bad, a lot of heat is going around the side through the bricks. So you fix that by cutting out the reveal here and putting some insulation in. So you've already got cavity wall insulation, but it stops just behind the brick. And so connecting it all up makes for much more continuous insulation, which is the secret to avoiding thermal bridges. So this is a messy job, cutting out a slot with an angle grinder. So this is just an attempt to keep all the brick dust in one bit of the house, and you end up looking like this. So this is the result. That's what a chopped out thermal bridge looks like with some insulation in it. And here's a nice new door with, and this is getting the air tightness right. So you stick a sheet to the door first, put it in the slot, and then you've got this flap to stick to the plaster on the inside and make a continuous airtightness layer. We'll get back to that in a minute. Oops, sorry. So on the outside of the building, the same principles apply. So this is the front door again. Last year, the year before. So when we got to doing the external wall insulation, these bricks would come out and be a thermal bridge. I mean, not too bad because of the cavity wall insulation, but still a problem. So I chopped those out and made sure the insulation was continuous from the cavity round the corner here to the external wall insulation. So continuous insulation is kind of the secret, especially if you're trying to get to passive house grade rather than just okay. Any gaps in the insulation is bad. Even if there's a relatively thin bit covering a problematic area, that's a lot better than nothing. So the other fundamental aspect of this is airtightness. There are a lot of holes in your house. I practically guarantee it, especially if it's old and has had a few decades of people changing kitchens around and plumbing and wiring and adding different internet providers and so on. They've all drilled holes in the wall, and hardly any of them filled them in again. So this is, behind your kitchen cabinets, there'll be plumbing going through a hole like this with a big wind blowing through the gap. So you can fix that by putting a gasket over it. So these are nice ProClimber pre-made gaskets, but you can do it with a bit of rubber sheet and some tape. Similarly, sockets should be taped up. We had, because the wiring was in the cavity on this house, apparently that's how they did things in the 60s, it's illegal now, the cavity wall insulation couldn't get to that bit because of the wires being in the way, so you tend to get a channel through the fluff, letting the wind blow a gale out of your sockets. So we fixed those. And similarly, if you've got, once you fit heat recovery, and if you put any of the pipes outside the airtightness layer, for example in the loft, you need to seal that up properly where it comes back in through the ceiling. So I've never actually done a proper airtightness test to find out how well we've done. It's obviously dramatically better than when we got it, but I haven't got a number. But what we did do was had this car radiator fan you can stick in the window, so you can at least pressurize or depressurize the house and go around feeling for gaps and drafts, which is quite effective. Slow. So the sort of thing that you'll find if you look between the floors is this. So this is a joist that's upstairs and that's downstairs, and there's a massive hole here with the cavity wall fluff falling out through it. That's why you need to not ignore the bit between the floors and go and fill in holes like that, so that it looks more like this when you finish. It's quite important to seal properly around joists. I'll explain why in a moment. So here's another example of why. So the point about airtightness is that it needs to be continuous. It's no good having one continuous layer and another continuous layer somewhere else. So if you imagine two buckets inside each other, if both of them had a hole in, even if the holes didn't line up, the water would still get out from the inner bucket through to the outer bucket and then through to outside. So that's why you've got to have one continuous line you can draw somewhere in the plans in 3 dimensions. That is the airtightness line. So on this house, we used the plaster. It's wet plastered. That's a pretty good airtightness layer, as long as it's not too cracked. And you can use this latex paint over it if you have got cracked plaster. It's good stuff. But you get a problem if, for example, you need to go up the wall and then round a joist to outside. And this only really applies to new construction. If you're building something new, this was our extension, the airtightness needs to go across the top of the timber and then round back to inside. So you need to stick a plastic sheet in beforehand, before you put the beam in. Otherwise, you can't do it after the fact. It's completely impossible to seal properly around the back of this. So this is an idea called a Tony tray, after a chap called Tony, who probably didn't invent it, but he's popularized the idea. It's a very good plan. This is where the Tony tray comes down below the ceiling, and I put a bit of tape to it, which is got this netting, so you plaster onto that and it'll join them up in an airtight way. And this is just all the taping around the windows to make sure. You do have to think quite hard about complicated 3D areas to get good airtightness. And this is at the top of the cavity. So cavities are a problem for doing external wall insulation. If you imagine if there was a big gale blowing up down your cavity because it was empty, you could put a lot of insulation on the outside wall and it wouldn't be doing anything because you'd have cold in the gap. So it's important to seal the top of the cavity and fill it so that you're not getting lots of air movement in that gap. You often see it on semi-detached houses. The party wall is often the cavity for noise reasons, but it doesn't have any fluff in it. So what happens is the air in there gets warm and then rises up straight out the top. So you'll see the snow line melts down the middle of houses because all the hot air is in fact getting up through the cavity. It was one reason why a lot of houses were much colder than the sums suggested they should have been a few years ago, before people realized about this problem and stopped doing it that way. You can also insulate the ceiling. Put membrane on the ceiling for airtightness. If you've got painted plasterboard, that's reasonable. You don't have to do this, but obviously a membrane is better. I've done that in one room so far, and I might do one more, but I'm probably not going to do the whole house. So eventually you've bunked up enough holes that you need a heat recovery system. So you need ventilation in a building, both to keep CO2 levels down and for moisture removal from cooking and people and clothes maybe. But the idea is that if that ventilation is through just the known holes, i.e. through this machine with a heat exchanger in it, you can get a good level of ventilation, but nearly all the heat gets sent back round again. So 85–90% of the heat stays inside the building, but you still get good ventilation, as opposed to just having lots of holes in the building and having a drafty building. Too many people think that a drafty building is good because you need ventilation. You go, no, you need ventilation through the holes you knew about, not a whole lot of holes you didn't know about, and then you can control it. So I did this with this metal piping, which is good, but I did find it was a tiresome job, cutting pipes to fit and sealing all the joints, because it's got to be airtight. And I spent 9 days in this cupboard doing piping over Christmas one year, and to be honest, got a bit fed up with it. It would be a lot quicker and easier to use flexible plastic pipe, and there's an Ubbink system which is very good, and it's also much easier to do the sums. I did all the calculations for airflow, the point being that you need to keep the airflow low enough, so airflow slow enough that it doesn't make a noise. So the pipe has to be big enough for whatever ventilation rates you need, which depends on the size of the room and what it's used for. But with the Ubbink system, you use a manifold, and basically it's either one pipe or 2 pipes for big rooms. That's it, dead easy. I have a spreadsheet if anyone wants to do these sums. It's not rocket science, and it will save you a lot of money, because people tend to charge, if you go to the Green Building Store, they'll charge you £3,000 to £5,000 for an MVHR system, and this cost us I think 1,300 or something. But yeah, quite a lot of DIY. I managed to hide it all, so this is flat pipe in between the floors, so there's no exposed pipe anywhere except in this cupboard and the loft. And it works very well. The air quality is excellent, and it feels really fresh, and it's improved allergies. It's good. I would strongly recommend it. So Skeilings. Skeilings are a terrible idea. My house has Skeilings. So if you've got a bit upstairs where the roof's at an angle like this at the corner, that is a Skeiling. So this is what it looks like. It's basically just a bit of plasterboard between you and outside. So it has terrible heat loss, and generally you'll find there is no insulation behind that bit because it's hard to get at. So one of the first things I did was fitted some. Oops. So you can see it here. Shoved some EPS down this slot. If I'd known better, I would have used PUR because it's better insulation, but I didn't when I first started. But I was doing that from the loft, so it's a miserable job lying in the corner of the roof trying to cut things to fit down this slot, and you can't really tell how well your job you've done at the bottom. So it's not till, again, a decade later when there's scaffolding, you get to come and take the bottom tiles off and actually see what you did and how well it works. However, once you've done that, you've still got a problem with this bit here. If you look, there's still only one brick between the inside and the outside. The cavity wall insulation stops at the top of the wall there, and there's this gap at the eaves. In most houses, the eaves is a bad bit, and it's difficult to get at and treat, but you really should plan to do something about it. So in this house, there was a brick covering, which probably reduced the air loss, and the fluff did actually come up to the top as well, which was good. I imagine it often doesn't. But anyway, I took those bricks off and put some actual insulation in, sealed the gap properly, and then filled in this corner piece with some fluff, which is a very fiddly job, and still not ideal because there's quite a lot of timber in there, which is still bridging to some degree. But you end up with, and then I put some insulation on the inside as well, and you end up with, now you've got a reasonable amount of insulation, and it is continuous just about, although there's a narrow bit just here, all around the house. So that is how you get to passive house levels of insulation. So the major job we did was internal wall insulation. And as I said, it's important to do the bit between the floors because that's where all the massive holes are. And also it's important to keep, to have a continuous airtightness surface and a vapor tight surface. So when doing thick insulation like this on the inside of a building, it's fine, but you do need to make sure it's properly sealed so you're not getting a lot of humid air getting behind it and condensing, because it will now be colder. You've still got the cavity wall fluff, so it's not super cold here, but it is cooler, and you don't want a load of water in there, especially where the joist ends are. So you want to take care with the detailing so it's actually all properly finished. And here's some nice finishing of taping around joists. I could talk about this for also hours. There's the various ways of doing it. That was the first version. This is the second version, which is a lot quicker and easier. And this is a version where there isn't any internal wall insulation. Use a bit of plasterboard. It just makes it easier. So yeah, that stops air moving down the ends of the joists and taking water with it and condensing. So that's why it's important. External wall insulation keeps all the thermal mass on the inside, which is a good thing. It keeps all the house dry, which is a good thing, and warm, which is a good thing. So you don't need to worry about bits getting cold and damp. So generally, EWI is technically better, but unfortunately, it costs more. So that is your fundamental choice. Or you can do a bit of both like this. There's nothing wrong with that. But it's a bit harder to make all the details work. So what else? Yeah, so on this side, we decided to change the glazing on this side when we're doing the EWI, partly because it's the north side and we had a bit too much glazing. There was a big window and a very small toilet for no good reason. And this kitchen window had one single, it was split into 4 with one single glazed pane because it used to have a vent through it, which was terrible and condensy. And also a great big bar across exactly at my eye height, so I couldn't actually look out my own kitchen window. And one of them was knackered. So we decided to replace all those. And then you realise doing the Passive House Plannage Package sums, which I must admit we didn't do right at the beginning. We just started because it's hard. That actually we could get to EnerPHit level if we did the whole house in triple glazed windows. So we were going to do it in 2 halves, just this half and then the other half, later, maybe one day. But it turned out delivery was so expensive that it was worth doing the whole damn lot in one go rather than paying £1,300 twice just to get your windows delivered. So that's what we ended up doing. Detail also windows. It's important that windows line up with insulation. So otherwise you get thermal bridges. So fitting the new windows, we move them out to where the insulation was going to go on the EWI side. So this isn't a great diagram, but hopefully you can see here's the window frame and that's attached to a compact foam block. So that's these white bits here. And then after that's all done, the wood fibers, one layer of wood fiber that's the same thickness as this, and then another layer that comes around the outside and covers over your frame. So it's worth understanding that with windows, the glass is generally the best bit and the frame is the worst bit. So the more frame you can cover up with insulation, the better. So that was this layout. Now, compact foam is quite expensive. So rather than just do the whole thing in compact foam, which would have been quicker and easier, we just did the structural bits and then put XPS in the gaps because I had lots of that spare. Bit fiddly, but it works. These aren't great pictures, but hopefully you can kind of see this is the window and that's that bit with the compact foam and the XPS here. And then the wood fiber now butted up against it. And then a bit later, here's the second layer of wood fiber coming over the top and hiding most of the frame. So there isn't that much frame visible anymore. And that's how it works. The other thing that's important is perimeter insulation. So if you pay someone to EWI your house, they'll just come down here and stop at the damp proof course and leave a big gap here. It's a bit like having a duvet sort of hovering 6 inches above the bed with a cold draft blowing past. It's really not very good. So because there's a great big thermal bridge through the floor slab, straight out through the ground, through the bricks and the ground to outside. Unless you put in this green piece here, so there's some insulation. And now you've made any heat has to go all the way down here and round through the foundation and back out this way. Now, soil isn't a great insulator, but 2 meters of soil provides adequate insulation. So this is a big improvement. It's actually not that hard to do. It's quite a good DIY job because it's mostly work. It's fundamentally straightforward. Dig a slot down the side of your house and put some insulation down there. The main problem is usually the drains and plumbing and rainwater goods down the side of your house. So, for example, we had these big kind of concrete gutter things, I can't know what the word is, with all your pipes go into. And it turned out to be like 1/2 ton of concrete under there. It was a big job to dig out, but I'm glad I did it properly. What else? We did this relatively high on the EWI side, mostly to allow for future flooding potential, because we're a bit of a local low point, and one day if there's a massive thunderstorm we might end up with a foot of water outside, and obviously that wouldn't be great for wood fiber. I forgot to talk about wood fiber actually. So you can do your EWI in expanded polystyrene or wood fiber are really the main choices. There are others. Expanded polystyrene is cheaper, but I didn't really want to cover the whole house in plastic and have millions of little bubbles from cutting it up in the garden. So I did it with wood fiber. It's got much more thermal mass. So especially if your house is prone to overheating, having some much heavier insulation makes a big difference. It's a thing called decrement delay, which is another subject we're not going to talk about today. It is more expensive, probably 25% more or something. It's not standard yet, and you've got to be more careful about waterproof details because you don't want your wood fiber to get all soggy. Oh yeah, so this is on the other side where we didn't have EWI. I just did the perimeter bit and then stopped at the damp proof course. It's a bit of a compromise, but it's a lot better than nothing. Yeah, so I'll pause there. We did an extension as well, and I can talk about that. But I thought maybe if there's questions people have on what we've talked about so far, now is a good moment.
There are a few in the chat. I can give them to you in the order they came. So, yeah. What floor plan software were you using on your slide?
I drew all the tech drawings. I used a thing called, it was called QCAD. It's now called LibreCAD. So I'm a free software Debian person, so I only use free software. Okay, apart from that SketchUp diagram, you haven't seen that there. In general, so QCAD was the best available. Unfortunately, it is 2D CAD, and for a complicated triangular building like this, it was annoying. These days, you can use FreeCAD, which is proper 3D CAD. So yeah.
Okay, and Tom was asking, how would you check for gaps in cavity wall insulations?
Yeah, so the reason we could tell that they hadn't done the whole half of a wall was because when you look, there's little round holes where they drill the hole and stick the nozzle in and then cement it back up again at the corners of bricks. So there just weren't any holes, so you could see that it hadn't been done. And a chap came along with an endoscope and shoved it in through a hole and went, oh yeah, there's nothing in here. So you can sort of tell by looking for the holes, and you can check with an endoscope. It's actually quite cheap. So you can get a USB endoscope now for 20 quid, which you just plug into your laptop and stick through, and you drill a 10mm hole, and you can see sort of what's inside.
Oh, interesting. Jason was asking, did you do anything about your roof ventilation when you insulated the eaves?
Yeah, so I did leave a gap. I didn't leave a very big gap. So there was, the whole height of the rafter, which was, I think it's 140 mil in mine. So I put 130 mil, something like that. So I think I put in 100 mil of insulation and left a 25 mil gap, which has been fine. Actually, we tested it really thoroughly because we had a bit of a plumbing disaster one year, and a whole load of water escaped into the loft and caused various disasters. But made a whole load of loft insulation sopping wet in January. It took 2 or 3 months to dry out, and nothing bad seems to have happened to my roof timbers. So I am happy that there is adequate ventilation. It's interesting because the soffits didn't have any ventilation holes like they really should have, so there wasn't that much, but it appears to be enough. And there's 2 holes, one at either end of the loft, drilled in the gable walls, which I think give most of the insulation and most of the ventilation.
Okay, I've got a couple more questions coming. Do you want to take one last and then
yeah, go on.
So again from Jason, he likes your windows details, but would you have problems if you need to replace the windows?
It is harder to replace the ones in the EWI with the way those compact foam blocks are screwed in. It will be a bit of a pain to change the windows. You'd have to cut through the fixing. There are other ways of fixing windows, like having a little metal strip going out from the reveal, which is how the window fitting people wanted to do it, but I didn't like the thermals on their detail so much as on my detail. But you're quite right, it's a bit of a compromise in terms of ease of replacement. But they're very posh windows. I'm expecting them to last at least 50 years and not be my problem.
Right. We've had a few more questions coming. Do you want to take them in or keep the rest for the
we
end?
could do, what was it, 35 past. I'll talk a bit more and we'll come back.
Okay. I'm not forgetting the questions.
Cool.
Yeah.
So we did an extension as well. I don't want to go into too much detail on this because it'll take too long. But we had a small kitchen with 4 doors, so it was almost all door. It's very annoying. So we closed one up because you don't need 3 external doors. But that meant that now you got wet using the remaining door getting to the garage, and that was annoying because it just had this little cover. So we thought we'd fill in this triangle, and then realized that actually you could put an extra room in here, and that would be a nice place to store your bikes and stuff. And so something like this. So that's basically filling in this triangle a bit and then a bit extra. Now, for complicated reasons, we did try talking to architects, but it was expensive and difficult, and I wasn't satisfied with the results I got. So in the end, I ended up again doing it all myself, do my own drawings. It did take a long time, but really it's not rocket science, and you do get what you want. It's complicated because it's triangular, so this bit is the sort of nexus of all the complicated timberwork angles, and we got Green Hat Construction to do most of the main work, and then we did the kind of interiors. And he did have to get his good carpenter in for this because it was a bit of a tricky job. So the main problem with an extension is that it's no easier than doing a whole house. You've got walls, you've got doors, you've got windows, you've got ceilings, you've got floors, you've got heating, electrics. You've got to do exactly the same amount of design work as for a whole building, which is a bit of a pain. So I stole a lot of details from the Green Building Store's first passive house with a cavity in the UK. So this is one of theirs. So basically that's a 200mm cavity. Which gives you a U equals 0.15, i.e. passive house grade wall. Oh dear, there go the lights. So, and also these are Teplo ties, which were pretty much brand new in 2010. So that's a basalt wall tie, which has much better thermal characteristics. So you're not losing heat down all the little wall ties. But basically it costs nothing to make your cavity twice as wide as building regs tells you to. So do that. Yeah. And not nothing, but the cost increment is so tiny as to be negligible, and we really should be doing this as standard. All similarly with floor insulation, it's very easy to put a load of insulation under the floor, but only whilst building it. It's incredibly difficult to do afterwards and hugely disruptive. So always put a decent amount of insulation underneath if you're building anything. Yes, else I was going to say, we quite a lot of attention paid to thermal bridges and thermal mass. So this was, we put quite a lot of concrete in the floor so that there was plenty of thermal mass because we knew we were going to have a load of glazing. And basically, if you have plenty of thermal mass, you get a steady temperature and places won't overheat. It was a little bit finger in the air as to exactly how well it's going to work, but it turned out to work very well indeed. It never gets below 10 or above 23, sorry, 11 to 23, and we don't need to heat it. And it's a really nice room to be in. It's got that sort of passive house vibe of a very steady temperature. For a long time, it was much nicer than the rest of the house until we've more or less finished the house now. So they're both pleasant to sit in. If you're doing an extension, the extension will join the existing building. One thing people seem to always forget to do is deal with the massive thermal bridge you get where the new building joins and the old bricks just go straight past, so connecting inside to outside. So here's the garage wall, for example. You, rather than just having a load of bricks going across, you cut a slot so the insulation in the wall goes straight through and connects to the insulation inside. It's not difficult. I thought my builder would charge a lot of money for this, but actually it took a day, so that's like 300 quid or something. Not a huge deal. So this is foam glass. Foam glass is really useful stuff. It's expanded recycled glass bottles. So it's very strong. You can build a whole wall on top of it. And yeah, so we put that in the foundation here to connect the floor insulation to the wall insulation. And we put it in the existing house wall. So you just chop out the bricks and put in this. I thought this would be done over 2 days. So you do half of it, let the cement set, and then do the other half. But the builder did it all in 1 day, and the house didn't fall down. So I guess that's all right. What else? Also, where the timber structure, again, separating the inside timber beam from the outside bits with a bit of fiberglass, really useful thermal break material. And this was the result, which I think is definitely an improvement. We also did the garage. Oh yeah, I meant to scroll back a bit, sorry. So next door had already raised their roof and the garage roof like this. So it made sense to do ours as well, to produce a, looked like that was always the plan because it was previously flat roofed. So this was, we did that work inside. So here's a useful little trick. If you're insulating a wall and you need to attach things to it, like radiators or in this case, garage shelves, rather than screw a big plank to the wall and have a thermal bridge, put one layer of insulation on, then put the bit of wood on and screw that through to the wall, and then put another layer of insulation. So this bit of wood is only halfway through the insulation. There's a few screws going all the way through, but that's all. Yeah, you know, it's little details like that that give you a better insulated house overall. And this was the floor. Again, we didn't dig up the garage floor, which was massive and concretey, because it was only a garage and workshop ultimately. So we put XPS on the floor and routed out slots for underfloor heating, which hasn't yet been connected up. It's only been a decade so far. Maybe one day it will be. I couldn't buy a decent garage door that had reasonable thermals, so I got a carpenter to make one. So essentially this is just a big 100mm sheet of polyurethane foam inside a timber frame. Turned out the carpenter was a good carpenter, but he was an enthusiastic naturist and insisted on doing that even when working at our house, which was a little bit weird, but there you go. And I did forget to put an extra second seal on. There should be a little step with the second seal, which would have meant the airtightness worked better than it actually does in practice. That was an omission. Yeah, I don't know if the naturist carpenter is still working or if somebody complained. So yes, costs. So a lot of this stuff is not that expensive. The solar thermal was 1,000, it was 800, and then we had to buy a couple more pumps over 12 years. Lots of internal wall insulation. It costs you some, but not a huge amount of money. Doors and plumbing and lofts and so on. So it's only really when you get to windows, proper triple glazed windows cost real money. I mean, we bought fairly fancy Internorm ones. You can spend probably about half of that by getting some standard PVC triple glazing. It's getting more standard now, and it isn't that much more. It's probably about 10% more than double glazing now. So really, if you're buying a load of windows, buy triple glazed, honestly. If you look back in 15 years' time, you'll feel very foolish to not have done so. And EWI is also significantly expensive. We paid the renderers to do the rendering. You can do it yourself, but the problem is that you have to render it really quite fast if you don't want to see the joins. And I wasn't convinced that I'd be able to do that. If you've got a couple of mates who can render, you could probably do it between you. So anyway, the net result is we spent something like £33,000 so far, which sounds like a lot of money, but over 14 years, that's £2.5 grand a year, which if you're not skint is not a huge deal. And the house is dramatically better than it was. There's also the PV, which in fact has made a profit because of the fit. And also we built an extension. Obviously extensions always cost money. So yeah, outcomes. What have we got from all this? Well, our electricity usage went down quite a lot. Most of that was fitting PV, but also fitting LED lights and fixing other things. Until this year, of course, when we've suddenly been at home for a whole year. So I get to use my electricity to run computers for work instead of work's electricity, and that's doubled our consumption. Our gas usage is tiny, mostly because we have a wood burner, and that's hard to measure exactly how much that is, but it's certainly gone down by about, I'd say, a factor of 5 from, you know, a fair amount to very little now. And the main thing is you get a much nicer building. It's not drafty, it doesn't have cold spots, it doesn't have moldy corners, temperature's steady, it's warm in the winter, it's cold in the summer, it's really quiet with triple glazing and all that wood on the outside. You don't get condensation, the air quality is good, So it's very nice building to live in. And you really start to notice when you go to other buildings, like we just went and stayed in a holiday cottage, and it was cold, noisy and drafty and horrid. So you get a little bit snooty once you've been living in effectively a passive house grade building. Advice, I think obviously not everybody is going to be quite this keen. I have done a lot of DIY, you know, it's a lot of weekends. I could have been doing something else. So if you don't really like DIY, this probably isn't the approach. But the point is that understanding the difference between good, bad, and excellent, so that if you're paying somebody else to do it, is important. So understanding a bit about the details and how you do things. And some jobs, you know, are like 6 times cheaper if you do it yourself, because it's nearly all time. So for a lot of people, that makes a lot of sense. Builders, it's very difficult to get builders to do good work. They always, you know, most people I think still want whatever's cheapest. So if you just ask for something, they'll give you cheapest, and they won't suggest, oh yeah, you could make the cavity twice as thick. Wouldn't really cost anything, unless you ask for that stuff. And the other thing, one thing I didn't do for the extension was specify an airtightness level. I should have done. So I don't think it's quite as good as it could be. Obviously, if they're working to a test and it's part of the spec, then you know you'll get there. It's the builder's problem if they haven't met it, not yours. And the other thing I think, so the thing I've learned from this is when we started, you know, we were a bit more interested in how much is all this going to cost, and you know, how the AECB retrofit seemed like a perfectly good standard. But if you think about how fast things are changing, if you try and imagine yourself in 20 years' time looking back, going, how much insulation do I wish I'd put in? I have never met anyone, I've talked to a lot of people about this now, who wish they put less insulation in. I met quite a lot of people who did a lot of work and realized they didn't do a very good job. And 20 years later, you know, the 30 mil of insulation they put in seems a bit feeble. And honestly, it could have been 3 times as thick, and that would have been better. So I try and get into that mindset when planning your work. It's difficult if you haven't got, you know, infinite money, but on the whole, putting in twice as much insulation doesn't cost very much. The materials are generally not where most of the money goes. There's lots of other details I could talk about, but I think that's probably enough for now.
Well, so, thank you, Wookey. It's an incredible tour de force, I would call it. Where to begin? I mean, there's still lots more questions coming in. So
yes, perhaps I'll start with an easy one. I think you partly answered. It wasn't part of your cost, so I assume you lived in the house throughout.
We did, yes, and that is a bit of a problem. You know, it's nicer to do this in a massive blitz while you're not living there. It's more efficient. It's probably cheaper. And it's less annoying, but now you have to have all the money up front, pretty much, or at least all the big jobs that you've got to do at the beginning.
You showed a couple of slides of the fabric on the roof being stripped away when you were working on the eaves and on the gable
yes
wall. You've got a weathering issue there, haven't you? I mean, what happens?
You have, but this summer it was glorious. That was basically, it was, the weather forecast said it was going to be glorious for 10, 12 days, and it was. So it was fine. We did. I mean, that is one problem with wood fiber actually over polystyrene is when it starts raining, it's a bit of a pain. You've got to cover things up. Yeah, it can get rained on a bit, but you don't want it to get absolutely soaked. And again, it was very nice and sunny in the middle of 2020 and nobody could go anywhere. So I basically spent 20 days doing wood fibering. It took quite a lot longer than I was originally planning, but it was gloriously sunny. So yeah, we did end up messing about with plastic sheets and planks towards the end, waiting for the renderers to turn up. Yeah, I mean, that's always a problem with building in this country. You know, if you know you can get it done in the next 3 days, you're probably all right, but it's going to take longer than that. Then yeah, at some point people buy those really expensive scaffolds with a whole plastic roof, so they know they can carry on. The other thing I'd say about living in the place is at some point you kind of get fed up of staring at half-finished walls with patching and mess. So we did actually, even though it isn't necessarily most efficient, you kind of need to decorate some things for the bits you're staring at all the time, just to kind of, it's just nicer. You know, it does. After about 5 years or so, you go, I really am fed up of staring at that mess. We should we should do that. We'll just do a bit of painting instead of building more things.
Right, I'll take the other questions as I had them. What plug-in meter did you use to measure the electricity consumption at the beginning?
It was a Brennstuhl, I think, originally. And I got a better one from Navitron, which did a better job at measuring low power. I think some of the cheap ones do give misleading results with some loads. Like ours seemed to suggest that our PIR lights were using an enormous amount of power. And I don't think that was actually true. I think it was the device being confused by an inductive load or something. So yeah, they do vary a bit, and certainly early ones they were really good for measuring fridges, but useless for measuring, you know, clock radios. But yeah, the one, unfortunately, Navitron went bust last year, so you can't buy it from them. But I mean, they're widely available. There's plenty. Look at some reviews for how well they work for measuring low power and different loads. But it's like under £20 for quite a good one.
Okay, great. No, thanks. What did you use for the insulation below the dam course, and how did you avoid bridging it?
Insulation below the damp course, we used XPS, extruded polystyrene.
All right, you might, sorry, mentioned. Yep, yeah. How did you join the EWI insulation with the IWI on the other side?
Yeah, good question. We didn't join it, we just overlapped it. And because there's a cavity, that's not as bad as it might be. So I did some sums and reckon that about 1.2 meters of brick is equivalent to a reasonable amount of insulation. So basically overlapped it by about a meter, a bit more than a meter. And I reckon that's a pretty good join. There are some questions about airtightness, which is why sealing the top of the cavity, I think, is necessary to get it all to work. You could drill a lot of, I know I have a friend who drilled, he had a semi and he was doing his half, but not the other half. So he just drilled a load of holes down the join between the houses and filled it with lots and lots of cans of foam. So it's better to do just EWI or just IWI, but I think an overlap is sufficient from a thermal point of view and some thought about what's happening with the air movement, depending on your situation.
Right. So are you ever going to go for EnerPHit certification?
No.
And somebody asked, and I share the question, I have to say, what people with non-engineering degree do to upgrade their houses?
Yeah, I mean, so obviously you can pay somebody else to do it, and that will cost you something like twice as much, possibly more. Yeah, I mean, none of this is that good. So part of the thing here is a 60s house is a 60s house, right? So I've done an awful lot of sums to make sure this stuff worked. But yeah, the next person doing it doesn't really need to do all those sums. They just need to go, right, I need to put 150 or 200 mil of insulation all the way around the outside and deal with the crappy bit at the eaves, and that will be fine. You know, not everybody, we shouldn't be treating all these similar houses as bespoke projects, because all the 60s houses on this estate are pretty similar and could be treated in a very similar way. And you know, similarly for a set of terraced houses, they're all much for muchness. So once people have worked out how to do them, doing the same thing again is straightforward.
Yeah. Have I missed something? I don't think so. Well, but Anne makes a point, the same as you said. You said that we warned our builders in advance that we were going to be picky about airtightness. And it's good to do that because you can push back afterwards if they, you know, want to charge extra. You've said it from the start.
It's a general thing that you need to nail your specification down as much as possible. There was a couple of things, because I was designing stuff myself, and it was like I didn't really know whether it was easier to build it this way or that way. And you kind of ask the builder saying, do you want to do this or do you want to do that? I don't really care. And he just says, pick one. And you go, okay. So I picked one. And he said, oh, well, that's not what you said in the original spec. So now I'll charge you a bit extra. And you go, oh, that's annoying. So yeah, any change basically is an excuse for them to charge you a bit extra. Even reasonably nice people like Green Hat will do that. So
Oh, is there a case for people on an estate clubbing together to come up with sound design or methods to apply on the whole estate? I don't know. It's a good question for you or for
yeah, I
anyone
think,
who
you
has an
know,
answer.
I've done my house, and Rob Leadham's done his just behind, which is extremely similar. He's done some slightly different things, but broadly similar. And yeah, pretty much every house on the estate could take a similar approach. Rob's is arguably a bit more conventional than mine. And yeah, I think people should definitely be talking to their neighbours. Anyone who's done work, if there's someone around the corner with a similar house, go and ask them what they did. Especially if they did it a decade ago and it was good then, because then they can tell you if anything didn't work.
Mhm.
That's
So
worth
would you
talking
consider
about.
becoming an advisor for house upgrades yourself?
Yeah, well, and that's part of, so like I said, the retrofit pub meets. So, you know, once a month we talk about this stuff. It's on the link on this slide there, ACB. So, you know, we just go to the pub, and if you've got a house and you're interested in improving it, but you're not sure what to talk about it, we don't necessarily know the answers, but you can talk to like-minded people, quite a few of whom have reasonable expertise. And yeah, I think there's enormous room for providing more advice to people to help them get started. Obviously, most people would really want somebody else to just deal with it. And I think there's really enough builders with the right expertise to go round, but hopefully they are acquiring that. Yeah.
And as put in the chat, Cambridge City Council is commissioning some experts to produce a retrofitting guide. Yeah.
Okay, good.
Right. Oh, were you worried? Oh, questions are still coming. Did I cut somebody in earlier who was trying to talk at the same time as me, or no?
It was me. I was interrupting the flow. I was going to ask you about how it's changed when you started this project in 2007. I don't think hardly anyone in this country had even heard of Passivhaus, or certainly not EnerPHit. This stuff must have come.
And EnerPHit, I think, hadn't been specified then. It appeared sometime in the last decade, didn't it?
So it's the project, the aim, your ambition will have presumably grown as your knowledge grew.
Exactly.
And how did it change from the beginning? Let's retrofit the house into having these specific exacting targets.
Yeah, well, like I said, we kind of started with the carbon light spec, which seemed like a reasonable retrofit. I think it still is a reasonable retrofit standard, right? If you're not super keen on doing a lot of tedious details, then I think the ACB retrofit standard is a good one to aim for. You still use the Passivhaus planning package to do the sums, you know, or just copy someone else's. But yeah, I think that's a good standard. But obviously, you can go further than that, and if you want to spend a bit more time and money, you can. So yeah, well, I mean, it like I say, it was a process. I spent a lot of time reading about this. I found it interesting. So I'm not sure there's any particular moment. Like I say, it was actually, I didn't do the Passivhaus planning package sums right at the beginning. I bought the software, but it's hard to get started just on your own if you've not done it before. You kind of need someone to show you the obscure bits. It's not actually that complicated. There's a lot of details to fill in and measure, but it's not fundamentally very complicated. You know, how big are my windows? How far back are they set? What are the walls made of? That's the thing. You have got to work out what you've actually got. But if you fill in all the numbers, it'll tell you what your house is. And then you go, okay, if I put these windows in, what does that get me? And if I put this much insulation on here, what does that get me? So it was once I actually did those sums, I went, oh, actually, I'm not that far off EnerPHit, really. Let's do the other half of the house a bit better.
But presumably when you started it, you were just going to retrofit a house, and somewhere along the line, it becomes a target-based process, which is far more exacting, and in fact is a much better way of doing it, isn't it? When I'm going to do this, even if it's not EnerPHit, you're sitting there with a target in mind. And
yes, and I think the PHPP thing is kind of the key to that. That's proven to be quite so. The problem is the UK uses the SAP, standard assessment procedure thing, which really isn't as good a tool in terms of doing the sums and then getting the actual results. So PHPP's proved itself over 30 years or something now to get, if you do the sums and then build that, you get something that's actually nearly that good. It's a little bit harder with retrofit to measure exactly how well you've done.
And if you don't want to grapple with PHPP, there are people. I can see Margaret's name on the chat coming up here. Who
Exactly. We know a few people.
And specified in specifically doing that for you, aren't there?
Yes. So yeah, and you'll need to pay someone. It does take quite a long time, so you'll probably need to pay someone a few £100 to get those sums done, and argue a bit about some options. But that's quite a good way, I think, of deciding what you should do with your house if you are trying to do a reasonably high quality retrofit.
Mm-hmm. Right, a question from
Margaret. The other thing I haven't said, actually, sorry, I'll get back to Margaret anyway, is you do kind of need to do the whole plan before starting much of the work, because an awful lot of these things depend on the other things, like where the windows are going to go depends on whether the insulation is on the inside or the outside. And that sort of thing. And if you're going to insulate the floor rather than dig it all up, that changes the height of the doors. So right at the beginning, we bought a new door and had to decide: are we insulating, on the floor, or are we going to dig it all up? Because your first decision 11 years ago is affected by this other thing that we haven't actually done yet. So that's the one thing that's not done yet, is a heat pump and insulate the floor. And it's not until the floor insulation's in that I'll actually get to EnerPHit level. So it's not quite there yet.
We've actually reached 8 o'clock now. We've done.
Nearly.
That's true.
Last question, Margaret.
Last question.
Yeah, go on.
Were you worried about rising damp when the below ground external wall insulation breaches the damp-proof course?
No, not at all. I think it's nonsense. XPS doesn't transmit water in a significant fashion, and this is East Anglia, so it's not that wet. So building control officers worry about it enormously and will kick up a fuss. But I think the paranoia about putting plastic insulation across damp-proof courses on the outside is unnecessary. I'd like to see some evidence to the contrary.
Are there any more questions? We could stick around a little bit longer. I'm available. Have you got to be away, Wookey, or can you stay?
Yeah, no, I'm happy to hang around and talk some more. We might want to officially close up.
Shall we ask for the
more or less on
feedback?
time, I guess. But
talk about feedback, perhaps for those ones to before some of us leave.
Oh, that's true. Yes. So what was it? There was this. So yes, there's a feedback form, and Open Eco Homes would like your donations for Cambridge Carbon Footprint, because I have been quite impressed at the amount of organisation that's gone into this exercise. So we are spending your money well, and and tell people about it. I got a lot out of visiting some Open Eco Homes 10 years ago. That was one of the ways I learned about how to do things. And yeah, so I thought it was finally time that I did a bit to give back, as it were. These slides will go online, so you'll be able to get to these links. And like I said, come to the pub meet if you want to talk in more detail about your project or this problem in general, like how do we fix all the houses in Cambridge, especially the people who aren't that bothered and haven't come to things like this.
And when and where is the next pub meet?
That is a good question. It's next week, I think.
It's next Thursday.
Yes. So Thursday, is that 23rd? I can't count. Anyway, yes, this Thursday, 7:30 p.m. at the Alex. So no, it's not. It's online on Jitsi. So go to the AECB website. I guess if I could copy a link out and then paste it in the chat. Does that work? No. There we go. No, that's completely the wrong thing.
Will the slides be shared, Tom?
Yes, they will.
The slides will be.
Oh, it's not a slide. Sorry. Yeah. Okay. Yeah, it's extra.
So, can I just say, Mark, I was going to apologise to everyone that it was so blooming interesting that I forgot to start the recording for the beginning of your talk.
Oh no!
And so I don't know. I noticed maybe 7:25 or something, about 20 minutes into your talk.
Oh well.
I'm sorry.
Talk.
I'm kicking myself. But the rest of it will be shared with you in your follow-up email, along with these slides and the chat with the links in that.
Yeah, okay.
Yeah,
Well,
you get lots of thank yous now coming. Yeah, it's really interesting
really
talk.
good. Is there anything else people wanted to know? How did I join the EWI to the? I don't have had that yet.
I'm ashamed of my questions compared to the other. But if you have a leaky VLEX you want to change, so just one window, would you get a triple glazed, like compact one, or would you wait until you have a bigger project on?
Well, if you want to replace the window, then yes. I mean, ideally, VLEXs will be quad glazed because, of course, you get a worse U value for a horizontal window from a vertical window. But I must admit, I couldn't quite bring myself to fork out for triple glazed VLEXs in the garage because they were quite expensive.
Yeah, the one I'm talking about is in the roof, but we don't even need it to flip. Do they exist? Like just a skylight is probably much better still for.
If it doesn't need to open, then yes, you can probably get a better insulated non-opening window for a lot less money.
That was my slightly small question.
That's fine.
That's the extent of my upgrades so far. Oh, great. Yeah, thanks, Anne. I don't think I forgot any questions now, and I don't know how many people are still in the chat. Yeah, quite a few. I guess if anyone wants to sorry, Mark,
make a comment.
take over. I'm just
Anyone wants to unmute themselves and make a comment? Now's a good time.
I'm just really pleased to hear this, Wookey. I've been wanting to hear what you've been doing for years. It's absolutely brilliant. They're very inspiring. This is I really like the way it's sort of ongoing thing, you know.
Yes, it's nearly mostly done at this stage, but not actually finished. And our house is still there's an awful lot of putting things back together to do. I'm much better at taking things to bits than putting them back together, sadly.
I guess you've still got a gas boiler, and so what are your thoughts about switching?
Yeah,
to
I want to get rid of that in due course.
Or,
obviously, we use it very little, so it doesn't matter too much. But yeah, most of the gas we use for cooking, I think, at this stage. But yes, I think a heat pump is probably on the cards fairly soon. We're kind of sitting around to see how much heat we actually need. We've had one winter. It was conveniently timed that it was all properly insulated just in time for sitting at home for a year, so that was nice. But yeah, we're kind of seeing how it goes before working out what to do. I'm tempted by a DIY heat pump.
Yeah, that'll be next year.
And is your electric all from? I'm sure in the summer your electric's obviously all from the solar, but what about in the winter? So your domestic hot water.
Yeah. Yes, obviously we import a fair amount in winter. I don't know exactly what the numbers are. I'm sorry. I'd have to look it up. Total consumption is like was just about 1,000 kilowatt hours a year, or 1,100. I think we got it down to about 900 before the great working from home. Nearly doubled it. It's one of these slides. Yeah, 800 it got down to in 2020, which is like half refrigeration. So we did go quite a lot of trouble. I went around like getting rid of old wall warts that just sit there being hot, and replacing them with, for things that we used a lot, it was worth buying a better power supply. Just those little details, they kind of add up over time.
This presumably doesn't include the contribution from your PV panels.
No, this is, it's a good question. I think this is probably, I can't remember which column I got that number out of. I think that's what we use. So some of that will be coming from the PV.
Mm-hmm.
But yeah, like I said, 85% of the PV just goes to the grid. I haven't bothered getting one of those eddy things to run the immersion off, because yeah, in practice we only ever use it when it's really wintry and there isn't much spare. And because we got solar thermal, it's kind of pointless. There's an interesting question. If you were starting now, whether you just cover the whole roof with PV and not bother with the solar thermal, probably, because it's more versatile. even though you get to collect less energy. Don't know, complicated question.
Well, Wookey, can I ask about your extra electric consumption last year? So you consumed over 800 watts more than 2020.
Kilowatt hours,
So
yeah.
So you're around
So
a
there
lot
was two
more.
things. I had a very low power TV server that was doing the TV recording, and that died. So I put a nondescript PC in instead, which probably uses 15 times as much electricity or something and has to run all the time, because I couldn't get the sleeping thing to work properly. And I brought a couple of computers home from work for doing work on, which again was a desktop instead of a laptop for half the year, which again was several hundred watts pretty much continuously.
Wow.
So yeah, so I think it was basically works computers and my specially chosen low power server dying. So I was using a nondescript. And the problem is that if you've got your electricity consumption down to really quite low, you really notice changing a laptop into a desktop. It's a big deal.
Mm.
Jason says that your consumption is tiny, and it reminds the UK average home is 3,500 kilowatts.
Exactly. So
year.
we're still only up to half the UK average. So I'm not too worried. But yes, there is still room for improvement.
Okay, well, I think we should wrap up tonight.
Yeah, I think that's it.
Fantastic.
Well,
session with you.
Thank you all.
Thank you all for coming, and we'll.
I hope that was useful, and I'll probably talk to some of you in due course.
Okay.